Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is spiral traversal of a matrix. So let's get started. Okay, so let's get started. Today's topic is spiral traversal of a matrix. So I took a matrix of 6 cross 5 size, so 6 rows and 5 columns. So what is the spiral traversal mean is we will start from here. We will go like this. We will print this all the elements like 1, 2, 3, 4, 5. And we will come again like this and we will print this all the elements again 10, 15, 20, 25, 30, and again we will go like this means we are coming from back. Okay, so like this mean 29, 28, 27, okay, 26, and again we are going like, okay, so like 21, 16, 11, 6, and again going like this 7, 8, 9, and again coming like 14, 19, 24. And again, going like this. I will continue here 23, 22. And again, going like this. And again, going like this. So 17, 12. And again, going like this. 13, like this. 18. So that's it. We printed all the elements. So that's it, the spiral traversal. So how we can do? Okay, so let's continue. Now, before going to that, I want to tell what is this min R, min C, max R, max C, min row. So, what is the minimum row? We are starting from 0. So, we have from 0 to 5, no? Minimum row is 0. Minimum column. What is the minimum column here? 0. And again, max row. What is max row? 5. And what is min max column? 4. So, these are very important things we have to keep it in our mind. Okay, now what I'm doing is I'm starting from, so we are traversal. What is the first one? The first one is top traversal. Like, let me take like top one. So we are first traversing this top wall. So what is fixed in this top wall? This top wall, the fixed one is this min row. Min row is fixed. What is moving? J. J is moving like this. Okay, so what I will do is, let me write for. So let me take I is equal to, what is moving here? Min column to max column. So let me take min column and I less than or equal to max column and I plus plus. So what I want to print? Just swap it. System.out.println. Okay, what I'm printing? Let me take this as matrix. So matrix of what is fixed here? So fixed one I will write in J always. Okay, so what is fixed here? Min row is fixed. So min row is fixed. So this row one is fixed. So J is fixed. This row is fixed. And I means column is moving up to min column to max column. So up to here top wall is printed. So 1 is printed, 2 is printed, 3 is printed, 4 is printed, and 5 is also printed because I is less than or equal to max column. Now, as this row is already computed, let me write like this, like min row plus is equal to 1, because I will not compute this row anyway because it is already computed. So I can increment my min row now. Okay, now my min row will be 1. Okay, now what is the next one? What is the next wall here? This right side. So let me write right wall. Okay, what happens in right wall? In right wall, see, already 5 is computed here. So we have to traverse up to, I want to print from 10 to 30. So what is fixed one here? What is fixed one? This max column. See, max column, for max column only, no? So this max column is fixed. So what is moving? from min row. This is min row. Min row to max row. What is min row? 1. What is max row? 5. So from 1 to 5 I am moving. So for I is equal to min row. Okay. I less than or equal to max row and I plus plus. So system.out.println matrix of, okay. What is fixed here? Column is fixed. So I will write J here and I will write I here. Okay. Up to here clear. Now, 10 is printed, 15 is printed, 20 is printed, 25 is printed, 30 is printed. As this max column is already printed, can I decrement to 3? Because max column is up to 3. This column is already computed, so no need of coming to again. So I will decrement my max column to by 1. So my max column will be now 3. So up to 0 to 3. That's it, because it is already computed. Now let me erase this and let me compute this bottom wall and this also left wall also. Okay, give me 1 second. Now let us continue with bottom wall. Okay, so this bottom wall up to 5 to 30 I already computed. Now I should start from 29 to 26. Okay, what is fixed here? The max row. Okay, max row is fixed here. So my J will be max row. Now what is my I? My I runs from this max column to this min column. Means my I is equal to max column and I greater than or equal to, greater than or equal to min column and I minus minus. So because it is decreasing from 3 to 0, it is coming. From third column to 0th column, it is coming. So I minus minus, what I will do here, matrix of, what I should print here, what is, what is fixed one? Row. Row is fixed one. So I will write J here and I will write I. Okay. Now what should also, here it is printed, it is printed, it is printed, and it is also printed. As you see, this max column is also computed. So what we should do now? We should decrement it by -1 because this is not max row now because it is already computed. So this is the max row. So to make this, I will decrement it by 1. It will be 5. Okay, now what is the last wall here? Left wall. Okay, so to this left wall, what I can do is, what is fixed one here? What is fixed one here? Min, sorry. Okay, so let us continue. So what is fixed one here? Min column. Min column is fixed one. So I will write J as min column. And what is moving from max row to min row? From 4 to 1. See, from 4 to 1. My column is fixed and my I is equal to max row to from I less than or I greater than or equal to min row and I will do I minus minus. Okay, then I will print my matrix of, okay, what I should write here, what is fixed, column is fixed, so I will write J here and I will write I. So what I should increment now, already this minimum column is computed because it will compute these all the things. So what I should decrement now, I should decrement this, I should increment the min column because my min column starts from 1 now. I will increment 1. That's it. So min column plus is equal to 1. That's it about this, all the things here. Okay, sorry, I forgot to write here. What we have decreased here, max row to minus is equal to 1. Okay, so this is about the spiral traversal. So likewise, it still continues until I want to say all the elements are printed. So how can you do that? How can you test that all the elements are printed or not? Initially, we'll take, let's say total T is equal to n into m, because every matrix contains n into m elements. And now I will take count is equal to 0. Then for in while loop, for every for loop, I will increment my count plus is equal to 1. Whenever the element is printing, I will increment count is equal to 1. Then I will check whether my count is less than t, only it will continues, otherwise it will stop. So in while loop I will write while my count should be less than t, then only I can compute the dot. Okay, so that's it about the spiral matrix. I think you have understood very well. Okay, now let us uh, do coding with this. Okay, so okay, let's start. So initially I will take int n is equal to matrix dot length. Okay, and int m is equal to matrix dot length but matrix of 0. Okay, so this is number of rows. Okay, and this is columns. Okay, now what I will do is, what is my int min row? Min row is equal to 0, and int max row is sorry. Okay, int max row is equal to, how many rows are there? N. So n minus 1, because we always follows from 0 based indexing. Okay, so and int min column is equal to 0, and int max column is equal to m minus 1, and I will take total is equal to uh, n minus 1 in, sorry, n into m, n into m, and I will take, let's say count is equal to 0. So while count is less than total only, then I will do all the things. So first of all, what is the first wall we have to compute? We have to compute the top wall. Okay, so we have to compute the top wall. No? I already written this all the code at the beginning of this video only. Okay, again I'm writing. So what is the first step here? First, int I is equal to, from min column. Okay, my j is fixed. No, let me take j also here only. Okay, and my I less than or equal to max column and I plus plus. Now what I will do is system dot out dot print ln matrix. Sorry, it's not printing. We have to return the list here. So let me take a list of integers. List is equal to new array list. Okay. Now I will add these elements into that list dot add matrix of. So what is fixed here? J is fixed. No, J is min row. So what I will do is J here and I here. Okay, likewise, and I'm also incrementing my count here, and here I should do some other condition check also, because I should always check whether my count is less than total or not. Always. Because at any loop, I'm writing 4 loops now for 4 walls. At any loop, there may be, for example, in this for loop only, my count is greater than total. It becomes greater than total. Then what I should do? Again, the elements are printing. So that I should write that for loop in this right wall, bottom wall, left wall also. Okay, don't worry. But before going to this, I forget to write, I mean increment by min row, because already my min row is computed. I want to increment that. Okay, now what I should compute? I should compute the right wall. Okay. Okay, same thing follows here. but some little changes. Okay, but some little changes. I'm taking this main column to main row and this main row to max column and this max row. Okay, so I plus and I'm incrementing this, and this is I, this is I, and this is J, and my max column should be decremented by minus 1. Max column should be decremented by minus 1. Okay, so this is about this right wall. Now let me compute the bottom wall. Okay, bottom wall. Again the same thing, but a small changes. What is that is? Okay, so let me continue. Here, bottom wall. What is I here? Max row. And what is fixed? Sorry, here max column. And what is fixed is max row. And again, it's totally something like greater than or equal to min column. And here I minus minus. Here Ji, okay. So max row minus is equal to 1. Okay. Now left wall. Again the same things here. Okay, you should change with I, J, that all. Okay. Max row, your main column, y greater than or equal to main row. So again I minus minus. Here it is I and J. Main column plus is equal to 1. So that's it. At last I will return list. Okay, let me check whether all the things are right or not. Okay, now let me run my code. I think it is not. Now let me run my code. Okay, accepted. Let me submit. Yeah, accepted. Okay, I'm not tracing out this code because I already explained at the beginning of this code. I already wrote this all the for loops and why I wrote here count less than or equal to total. Okay, and for each for loop also I wrote this one because for example, let me take at this for loop, all the elements are over, all the elements are printed. Now, when coming to this for loop, I should also check whether my count is less than total or not. Otherwise, what will happen? Again, the already printed elements will be printed. So that is the reason this condition I wrote in every for loop. At last, in while loop also count less than total. So that's it about this matrix traversal. Okay, friends, thank you. Thank you for watching. The coming up video is exit point of a matrix in Java. Okay, so let's wait for this video and subscribe to my channel Quick Coder to get notified for the further videos. Thank you for watching.